Having a look at question 14 of the 2023 Maths Methods tech-free paper. So for question 14, we have the rate of change in the number of bacteria in a science experiment. We're given the equation for that, and we're told that T represents the time, hours since starting the experiment, P represents the number of bacteria in thousands, and it says initially there are 60,000 bacteria. They've even given us the little clue that P of 0 is equal to 60. So obviously we've got the rate of change. We want the equation for P. So we need to integrate that. So if we've got dP on dt is equal to e to the 2t, we want to integrate that to get what P is equal to. So when we integrate that, we're going to bring down that half in front, e to the 2t. And that will be plus c. Now they've told us initially there is 60, so that's the way that we can solve for the c. So we'll write 60 is equal to a half e to the 2t plus c. And we're putting in t is equal to 0, so we've got a half e to the 2 times 0 is 0 plus c. We know that e to the 0 is 1, so we've got a half plus c is equal to 60, so that our c must be equal to 59.5 or 59 and a half. And so when we write our equation, P of t, it's going to be that half e to the 2t plus 59.5. Then we've got determine the number of change in the number of bacteria during the third hour. Express your answer in terms of E. Now normally when we're looking at change in, we would be using that initial equation, but because we've been asked to find the number for the equation for the number of bacteria, and they've also said this key phrase here, during the third hour, this gives us the rate of change at a certain number of hours. So to do the during the third hour, we need to sub in 2 and then sub in 3 to find out what's happening during that third hour. So I'm going to find out P of 2 and then P of 3. So I've got P of 2, I've got a half e to the 2 times 2 plus 59.5. My P of 3 is going to be a half e to the 2 times 3 plus 59.5. So I've got a half e to the 4 here plus 59.5, and I've got a half e to the 6 plus 59.5. Now the change in those numbers then is going to equal my half e to the 6 plus 59.5, take away my half e to the 4 plus 59.5. So obviously those 59.5s are going to cancel out. So I'm left with a half e to the 6 minus a half e to the 4. Now if I wanted to, I could take that half out and factorize it. Part C says determine how long it will take for the number of bacteria present to double after starting the experiment. So in our question we were told there was 60 at the start, so we're going to have 120 when it's doubled, and our equation that we got was a half e to the 2t plus 59.5. So we need to solve for when that will be equal to 120. So our first step, we're going to take that 59.5 away. So we're going to get 60.5 when we do that, and we've got a half e to the 2t. Then we are going to obviously divide by a half there. Dividing by a half is the same as multiplying by 2. So we get 121 is equal to 2t there. Then to try and get the t on its own, we'll do the ln of both sides. We can bring that 2t down the front, ln of e, ln of 121. We know that ln of e is equal to 1, so we just get the 2t there. And then to get the t on its own, we're going to have a half of ln of 121, and that's our answer. For question 15, we're into some probabilities. Now, at first read through, it does seem like it's a fairly simple type of question, and yes it is. So we've got in a certain game, players throw one water balloon at a target. There's a 1 in 4 chance of hitting the target. State the probabilities of all the possible outcomes for one throw. So in one throw, you can either hit or you can either miss. They're your only two options. So your probability of hitting is going to be 1 on 4, and your probability of missing is going to be 3 on 4. That's all that one is. 2 marks. Nice and easy. Then we've got part B. Let h be the discrete random variable for one of the possible outcomes. Determine the mean and variance of the distribution of the random variable h when 20 players throw a water balloon at the target. So our mean, if we know that we have 1 in 4 hit the target and we've got 20 players, we're doing n times p, so that's 20 times 1/4, which is just 5. Again, nice and straightforward question. Then the variance, we know, and I'm used to writing that as NPQ, but in the new format we've got 1 take P instead of Q. So we are doing 20 times our 1/4 times 3/4, which then gives us 60 over 16. We can then reduce that down to 30 over 8. We can then make that a mixed number by saying 8 goes into 30 3 times with 3 times with 6 left over, and our 6 on 8 can be reduced to 3 over 4. So we've reduced that down to 3 and 3 over 4 as our answer. For question 16, now at initial glance I did think this was quite a difficult question, well, more a trick question, because looking at that, it does look a little bit tricky to start. We're used to seeing for a quadratic type 1 where you might have the 4x and the 2x there. This is one we're going to treat as a quadratic, but they've given us negative 2x and 2x. I feel a little bit of a mean question. So your first step is you're going to multiply by e to the 2x to start with. So that means you'll get 4e to the 2x, and then you'll get 7, and that will just be e to the 0, so it'll just be 7, and then we'll get 3e to the 4x there. We then want everything on the one side, so we've got 3e to the 4x, take away 4e to the 2x plus 7, and this is where we can then write this as 3e to the 2x squared minus 4, I've missed my e there, e to the 2x plus 7, and now it becomes more obvious that it is a quadratic type. I like to go through and say e to the 2x is equal to a, just to make it easy when I'm factorising it. So I write 3a squared, take 4a, and oh sorry, that should be a minus 7 there, lost my minus. And so now I can factorise that. So my AC is equal to minus 21, my B is equal to minus 4, and so my AC, so my two numbers that are going to multiply to give negative 21 but add to give negative 4 are negative 7 and positive 3. So then I will write 3a squared take 7a plus 3a take 7. I can factorise by taking an a out of the first two terms, 3a take 7, a 1 out of the second two. So my two brackets are then a plus 1 and 3a take 7. This is where I then put my e to the 2x back in, because if I've got a 0 there, I know that either that bracket has to equal 0 or this bracket has to equal 0. So then I can write my e to the 2x plus 1 must equal 0, or my 3 lots of e to the 2x take 7 must be equal to 0. So solving this one, I would get e to the 2x is equal to negative 1. That I can't go any further with. That's not possible. So over here, I'm going to finish solving this one. So 3e to the 2x is equal to 7. Then I can make that e to the 2x is 7 on 3. I then want to do my ln of both sides. So then I'll bring down that 2x. My ln e is just equal to 1, so 2x is equal to ln of 7 on 3. And then my x will be a half of ln of 7 on 3. Obviously, if you're in an exam and you're going outside the box, make sure you use some extra paper. And I'm going to finish my video there and continue on with the rest of the questions in another video.